All right, so we're actually going to come back to like the formula, if you will, on finding a coefficient or a term. I think it makes a lot more sense if we just kind of do it. So we know a lot of our patterns right now. So right here, if I want to find the term containing x to the fifth of this, okay, so because it's a 7, we got to think, okay, we're going to have 7 choose. Now, because when we think about setting this up, okay, I want x to the fifth. So I'm going to put x and -3. These are my two different pieces in my binomial, right? Now, if I want x to the fifth, I'm going to put a 5 right there. And then I'm going to take this -3 and I'm going to have it to the second power. Now, where did that 2 come from? Okay, well, that 2 is coming from, because this is a 5, that has to be a 2 because I know that they need to add up to be a 7. Okay, so now what's the number going to be that goes right here? It's just whatever this one is. Okay, that second one. So I'm going to put that 2. Now, a little bit of an insider secret. If you accidentally mess up and you put that 5 there, it's not a big deal. Okay, because of the symmetry, it's going to work out fine. So if I want to find the term that contains x to the fifth, you see we kind of set it up. All right, we're using those same binomial theorem patterns that we saw before. So I'm going to go ahead and type my calculator. 7 choose 2. That's going to tell me 21. And then x to the fifth is just going to be x to the fifth. So I'm just doing that coefficient right now. And then -3 squared is going to be a positive 9. So if I take that 21 and I multiply by 9, now I get 189 x to the fifth. So this right here, this is my whole term. Okay, that's going to be a little bit different than if I ask you for the coefficient. The coefficient is going to be just the number. So we got to kind of just make sure we're paying attention to the lingo. So we're going to practice that same process and say, okay, find the coefficient of the term containing y to the third of this binomial expansion. So because it's an 8, I know I'm going to have an 8 choose something. I'm going to deal with that in a minute. Right now, I'm going to take my first term, that 2x, my second term, -5y. Now, if I want y to the third, where's the 3 going to have to go? With the x or with the y? Well, hopefully that was obvious. It's with the y. So if I have a y to the third, and I have this binomial expansion of an 8th, that means this guy here has to be a 5, because remember, those have to add up to be the 8. And we're going to stick that 3 right here. So now I'm going to take my calculator, 8 choose 3. That's going to give me 56. I'm going to take 2 to the fifth, which is going to give me 32. And I'm going to take -5 to the third, which is going to give me a -125. So we've got to be really careful with those negatives. So now 56 times 32 times -125 is going to give me -224,000. Now, if I was asking you this right here, this is the coefficient. Okay, so that's actually all this problem is asking you for. If I wanted the actual term, I'd have to stick on an x to the fifth and a y to the third with that. All right, so honestly, I'm not even going to write anything down here. You can copy that off Buzz if you want, but once you start throwing things up there, there's n's and there's k's and there's n minus k's and there's r's, and it just gets really confusing. So if you really understand the pattern, I think you're going to be in a whole better place. Okay, so let's talk about binomial experiments. So binomial experiments are going to be experiments where either one thing's going to happen or the other thing's going to happen. So it's like you're going to flip a coin. You're going to flip and get heads, or you're going to flip and get tails. You're going to roll a dice. So if you're rolling a dice, there's lots of things that could happen, but it's like, okay, you're either going to roll a 3 or you're not going to roll a 3. Okay, so it's either going to happen or it's not going to happen, but there's one specific thing that's going on. So that's why it's a binomial experiment, because there's only 2 choices. It's going to happen or it's not. So as we look at this binomial experiment, the probability of k successes, it's a really terrible k. Okay, so the probability of getting some sort of success comes from this formula right here. So don't freak out about this. So this is the probability that it's going to happen. Okay, now because it's either going to happen or it's not going to happen, think about it. There's a 100% chance that it's going to happen or it's not going to happen. So you take 1 minus the probability that it happens, and this right here is the probability it doesn't happen. Okay, and these exponents, don't panic about those exponents, k and n minus k. right? Well, just think about that. Remember that these here have to add up to be whatever that outside number is. So again, don't get so hung up on the formulas. Let's just try some of these problems here. Okay, so maybe you want to know here, this is like the total, and this is what we want. Okay, the number that we want, the number of successes. Okay, so calculate the probability of tossing a coin 25 times and getting tails twice. So you know that if you're tossing a coin 25 times, you have a 50% chance to flip heads and you have a 50% chance to flip tails. So the probability of success is 1 out of 2, or 50%. Okay, so we're going to always be thinking about that as like decimals or fractions. So the probability of success, and success is getting a tail, so that's what we want. Okay, so as we think about this, the total, so we're flipping a coin 25 times, so 25, choose the number that we want, the successes that we want. So we want to get tails only 2 times, so 25, choose 2. Now, the probability of success, this is what the probability that it happens, this is success. Probability of success is 1/2. Okay, and then the probability of failure, this would be failure, okay, is 1 minus 1/2. So failure is going to also be 1/2, right? 50-50 shot, heads or tails. So the number of successes that we want is 2. So if we have 2 successes, what does that mean about the number of failures we're going to have? Well, that's going to have to be 23, right? Remember, going back to the binomial theorem, that these have to add up to be that 25. So now we're going to type this into our calculator. So we're going to get really tiny numbers because probability. So 25, choose 2, times 1/2 to the second power times 1/2 to the 23rd power. So I'm literally typing that straight into my calculator, all of it together. Sorry, it's so grainy. And we're going to leave that as a decimal. So we're going to get 0.1, 2, 3, 4, 5 zeros, and then I'm going to just do 8941. I'm just going to write that all out right there so you can try your calculator and make sure you get the same thing. When you're typing your answers in on Buzz, just make sure you're watching for whatever you're rounding to. Just be careful. Okay, let's try one more of those, and then we're going to be all done with this, and you're going to be doing just great. So calculate the probability of randomly guessing 7 correct answers on a 15-question multiple choice exam that has choices A, B, C, D, and E. So we've got to first figure out, okay, well, what's our probability of success? Okay, well, in multiple choice, there's only one right answer and all the other ones are wrong. So if we have answer choices A, B, C, D, and E, that's 5 different answer choices. So probability of success is going to be 1 out of 5. So the probability of failure is going to be 4 out of 5, right? 4 of those answer choices would be wrong. So as we think about go back into the formula, right? The total, choose what you want. So the total questions, 15, and we want to get 7 correct. That's our successes. So now my probability of success is 1 out of 5. My probability of failure is 4 out of 5. So how many successes do we want? 7. We want 7 of them to be right. So if 7 of them are right, then that means 8 of them have to be wrong because there was 15 questions, right? Remember that those have to add up to be that 15. Okay, so typing that into our calculator. 15, choose 7 times 1/5. Probably should put some parentheses. To the 7th times 4/5 to the 8th. So, well, that was cool. My calculator just died on me. Literally died. Okay, okay, back in business. I don't know, it's too dark here in my dungeon of a basement to get this number. So we've got 0.013819 0.057. Again, I'm just going to write everything I see on my calculator right now because I didn't specify decimal places. Just use your judgment based off of whatever Buzz is saying. All right, you guys got this. Okay, don't get hung up on the formulas. Just make sure, like don't get overwhelmed by this. Okay, success, failure. What you want, what's left over. Okay, now sometimes, let me give you a quick little warning. Sometimes it's not going to be like 1 out of 5 or 1 out of 2. Sometimes they'll straight up tell you you have a 30% chance of success. You got to then use your little noggin and say, okay, if there's a 30% chance of success, make sure you're converting those percentages into decimals. If there's a 30% chance of success, well, then that means how much of a chance of failure is there? 70%. Okay, so percents to decimals. Don't forget to do that. All right, you guys are awesome.